Interesting, right? Well, I have designed a microcontroller based single phase induction motor starter. So let's see how it works and how can it be useful in industrial sector. So let's get started. Let's understand the schematic representation first and then I will come to the actual circuitry. So here is the schematic representation. Here, the Arduino Nano is the brain of the system. It is programmed to do this operation. So, at first, I will discuss the connections and then I will explain the logic and its working. See, the digital pin 2 of the microcontroller is connected with the base of the transistor via a current limiting resistor. And pin 3 of the microcontroller is connected to the green LED. Pin 4 is connected to the red LED. And pin 5 and 6 is connected to the ground, that is 0 volt, via two push buttons. A relay is connected in series with the transistor. Also, a freewheeling diode is connected in parallel with the relay. And finally, an induction motor is connected to the mains, that is 230 volt AC supply, via the NO contact of the relay. And the control system is powered with the separate DC supply of 12 and 5 volt. 5 volt for triggering the relay means the relay's power supply is 5 volt and the microcontroller's power supply is 12 volt. So I needed 12 and 5 volt separate DC power supply. So I have given there. So this is the connection. Now let's see the logic and its working. Well, when start push button is pressed, pin 5 of the microcontroller gets pulled down to 0 volt and eventually the relay gets activated. Also the green LED lights up and the NO contact of the relay becomes NC and the motor starts. And if stop push button is pressed, pin 6 of the microcontroller gets pulled down to 0 volt, which de-energizes the relay coil and triggers the red LED. And henceforth, the NC contact of relay again becomes NO, resulting the motor to come at its rest position. Well, the logic is very simple. Okay, when pin 5 is equal to 0 volt or rather low, the pin 2 sends high signal to the base of the transistor and pin 3 sends high signal to the green LED and pin 4 sends low signal to the red LED. Thereafter energizing the relay coil to start the motor. On the other hand, when pin 6 is equal to 0 volt, then pin 2 sends low signal to the base of the transistor and pin 4 sends high signal to the red LED and pin 3 sends low signal to the green LED, thereafter de-energizing the relay coil to stop the motor. Okay, so let me show the practical overview. See, here this one is the Arduino Nano. Okay, these two are the push buttons. This is the transistor, this is the freewheeling diode, and this one is the current limiting resistor. These two are the LEDs for indication. This one is the green and this one is the red. And finally, this one is the relay. Okay, when this push button is pressed, the relay gets activated and henceforth the motor turns on, creating this green LED to light up. See, like this. Okay. Now if I press this push button, the relay de-energizes, means the relay's coil gets de-energized and its NC contact comes back to NO position and the motor stops. Okay, see. the relay activates, the relay coil gets activated, the NC contact becomes NO, the NO contacts become NC and the motor starts. And now if I press this stop push button, the relay coil de-energizes and its NC contact becomes NO and motor stops. Okay. Well, this kind of setup can be useful in industrial sector because this type of motor starter is very much reliable, gives protection. This system can also be modified to enjoy more features. Okay, so that's it. Thank you for watching this video.